All right, everything seems to be working so far, so we're gonna go with it. Except I should probably plug in my smart board so that it works. Okay. So, yeah, I sent out reminders to people that still have to turn some stuff in. So you'll get a campus email, or you should have gotten a campus email about that already this morning because I sent it out about an hour ago. Yeah, so we got that going on this week. We've got some slope and rates of change today. Tomorrow is graphing lines. So you'll need some graph paper. So I should write a big old note that says put graph paper on its learning. Paper. It's. Okay. And then Wednesday and Thursday we'll be writing some equations. Excuse me. And then you'll have a formative coming up on Friday. And then this week we'll have a worksheet again. And so then that worksheet will be due next Sunday at midnight, or at 11:59 p.m. Okay? All right, so let's get into it here. We're going to be talking here with slopes and rates of change today. So we're going to be finding the slope between two lines and deciding the big part about today is the parallel and perpendicularness of lines. Okay? So what is slope? Okay? So what is the concept of slope? Well, slope is the steepness whoa, why did that switch back to red halfway through? That was kind of funky. I'll hang over here this far. Come on. Or pitch. Why is it switching back to red? We got funkiness, sheer funkiness going on here today. Just do this. Of a line. Okay? It is how much if we're thinking about it in terms of function notation, okay, it is the increase or decrease amount. Yeah, I'm done writing and yet it's still coming out. So I got to make sure that everything's spelled correctly and in the right spot. Oh, look at that. Perfect. Okay? All right? So we got all that. Okay? The methods that we can use to find the slope of a line, the methods that we can use are, it's always rise over the run if we have the picture. So if you actually have the picture of a line, you can determine the slope by the rise over the run between two specific points. We can look at y equals mx plus b. And in that, we can determine that the slope is the coefficient of our x term. M is slope, okay? So the symbol for slope is m, and that's actually because it was a French mathematician that determined the concept of slope way back many, many moons ago. And in French, or in the French language, I should say, he associated it with climbing a hill. He lived in a hilly area, and he noticed that the different hills had different pitches, and so he called it the slope because of the slope of a hill, and he used the letter M for monter because monter in French is to climb. So little backstory there for you on the slope. Okay? That's one. Those are two ways to find it then. But the tried and true method that you're going to probably use, I would say 75% of the time, is you are going to realize that the slope is the subtraction of the y's over the subtraction of the x's. Okay? And that order does not matter of the points. So we could go here, m equals y. Whoa, why did it switch back again? M here could equal subtracting the y's over subtracting the x's. So the order doesn't matter as long as the x and the y stay consistent from point to point. Okay? And that should have been things that you have all seen at some point in time before. Okay? There are 4 different kinds of slopes. Okay? There are positive slopes first. Okay? A positive slope would be like m equals 5 or y equals 5/3 x plus 7, we'll say. Okay? Those are 2 different examples of positive slopes. Okay? How it would look on a graph, your graph would go up and to the right, or down and to the left. And that would be your description. It would go up and right, or down and left. A negative slope m equals -5 or y equals -5/3 x plus 7. Whoa, that breaks. Almost tripped and killed myself right here on many of these cords sitting around my room. It would look like that. It would go down and to the left, or excuse me, down and to the right, pardon me. Or up and to the left. We can have a 0 slope. A 0 slope would be m equals 0, or y equals some number would be the equation. A 0 slope is going to have no rise but plenty of run. and we describe that as horizontal. And lastly, we have an undefined slope. The slope here would be m equals undefined, or the equation would be x equals some number. Further on those. So, yeah. That's going to look like this. It's going to have all the rise in the world, but no run. And so we call that vertical. So those are the 4 different types of slopes that you can have in this world. The nice part is that those are the only 4. Okay? Slopes are very particular. They only have 4. You only have 4 choices: positive, negative, 0, or undefined. Okay? Question of the day. The whatchamacallit? Yeah, you know what I call it. The attendance question of the day today is, what is your favorite pizza place? If you're calling for a pizza and you really want to have this kind of pizza, what would you be calling? Okay, type it in the chat. If you're watching this live, if you're watching this video, send me an email with your answer to the question of the day. What is your favorite pizza place? So then let's get back into doing some math. On these particular 4, what I would like you to do is I would like you to find the slope of the line passing through the following 2 points. Then tell me if it rises or falls to the right, is horizontal or vertical. It's just the description of what it is, okay? So finding the slope and then telling me what it does. So first one, I have 2 points. So in the thinking of how to do this, I'm going to use that point form, or the 2-point form. So I'm going to use m equals y sub 1 minus y sub 2 all over x sub 1 minus x sub 2. Now remember that points are x, comma, y. Come on. Got a big time lag going on. Okay? So they're x, comma, y. So it's not negative 3 minus 5 over 5 minus negative 2, because that would be x minus y over x minus y. It's y minus y over x minus x. So this is going to be 5 minus negative 2 all over negative 3 minus 5. If you want to work left to right, that's fine. If you want to work right to left, that's fine too. If I worked right to left, I'd have negative 2 minus 5 all over 5 minus negative 3. Okay? And that works also. Okay? 5 minus negative 2 is 7. Negative 3 minus 5 is negative 8. Or, if I was doing the green ones, negative 2 minus 5 is negative 7. 5 minus negative 3 is 8. We get the same thing there. So the slope between these 2 lines here is negative 7/8. And that would be a falls to the right case, because it's a negative slope, so it's going down and to the right. So that's a falling type case to the right. A little more space here. Okay. Try this next one here. Okay. So again, I would subtract the two y parts. 8 minus 8 over 7 minus negative 8. 8 minus 8 is 0. 7 minus negative 8 is positive 15. 0 divided by any number is 0. So the slope here is 0, which makes this be a horizontal line. Okay? What I would like you to do now individually is I would like you to do the next two, C and D. I would like you to do those on your own. I'll give you a couple of minutes here to find me the slope and the description of those lines. Okay? There it is. Found it. Okay. So in this first one, negative 1 minus 5 all over 3 minus 3. So that's going to be negative 6 over 0. Anytime we divide by 0, that's naughtiness. That doesn't work out. It's not possible. So the slope here is undefined, which means then that this is vertical. Fractions are our friends. We love them. Okay? So 2 minus negative 4 divided by 3/4 minus 1/4. 2 minus negative 4 is positive 6. 3/4 minus 1/4 is 2/4 or 1/2. Dividing by a fraction is the same as multiplying by the reciprocal. Okay, so this is the same as 6 times 2 over 1. 6 times 2 over 1 is 12. So the slope here is positive 12, and that one would rise to the right. Thumbs up if we're good. Okay. Lots of you have your cameras off, so I have no idea what you're doing, but I'm hoping that you're giving me a thumbs up from behind your screen. Okay. Next, we have to talk a little bit about parallel, perpendicular, or neither. Okay? So the first one that we have to talk about is parallel. Okay? So if I have parallel lines, okay, those are lines that never intersect. Never, ever, never, 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 ever, never intersect. Okay? And so if that is the case, if they never, ever intersect, their slopes are equal. Okay? And they would always be equal. Okay? So the slopes of parallel lines are equal. Perpendicular lines are a little different. Okay? Perpendicular lines intersect at a right angle. And that's what the definition of a perpendicular line is. They intersect at a right angle. And the slopes of perpendicular lines are opposite reciprocals. Okay? So there's two parts to that. Okay? The opposite tells me that one is positive and one is negative. Okay? So that's your automatic first check on perpendicular lines. One has to be positive, the other one has to be negative. If they're both positive or they're both negative, they can't be perpendicular. Okay? And reciprocal, remember, is the fancy mathematic word for flipping a fraction. Okay? So if one is 1/2, the other one would have to be -2 to be opposite in reciprocals. If the fraction is 7/5, then the reciprocal fraction would be 5/7. Okay? So if we have a slope, so if our slope is A over B, come on, A over B, there's A over B. Okay, so if that's our slope, then to make it become perpendicular, our slope now becomes negative b. Whoa, what happened there? Whoa, we got lots of stuff going on there. Oh, come on now. I want this to say done. Okay, now come back to me. Things just kind of went haywire on me there. So the reciprocal, or the opposite reciprocal then, would be negative b over a. Okay. Perpendicular. So parallel, same slopes. Perpendicular, opposite reciprocal slopes. Everything else is the neither case. Okay? So you can only be parallel, perpendicular, or neither. Okay? Let's try one. Okay? So are these lines parallel, perpendicular, or neither? Those are my three choices. So the first thing that we have to do is we should find the slope of both of those lines. So the slope here is going to be negative 1 minus negative 2 all over 5 minus 6. Negative 1 minus negative 2 is negative 1 plus 2, which is positive 1. 5 minus 6 is negative 1. So the slope of this line is negative 1. Slope of the second line. So now we have to go 3 minus 8 all over negative 2 minus 4. 3 minus 8 is negative 5. Negative 2 minus 4 is negative 6. That reduces to positive 5, 6. Okay? Because a negative divided by a negative is a positive. Are they the same? Yes for thumbs up. No for thumbs down. Maybe don't give me anything. Okay? I'm seeing a lot of thumbs down. Okay? Yep, thumbs down. So they're not the same. So they're not parallel. Are they opposites? Is one positive and one negative? Yes. Okay. Are they reciprocals? Is the reciprocal of 5, 6, 1? Nope, that's not it. So they're not perpendicular. They're opposites because one's positive and one's negative, but they're not reciprocals. So that's not the case. So then the only other choice is they are neither. Okay? So this is a neither case. Okay? Parallel, perpendicular, or neither is the case. Okay? Same type of question, except this time I would like you to try it. Okay? Give me a parallel, perpendicular, or neither, and I will go through it here in a couple of minutes. Those of you that just joined, the question of the day is, what's your favorite pizza place? Or some of you haven't typed in one yet either. I get a slope of 1/9 for the first one. I get a slope of -9 for the second one. They are not the same. They are not parallel. The reciprocal of 1/9 is 9. So they are actually opposite reciprocals. So these two are perpendicular there. Yeah. Perpendicular for that one. Yeah. Love it. You also might see some problems like this. Find the value of k so that the line through the given points has that particular slope. There is one like this on the worksheet for this week, and NTC likes to have these type of questions. I actually added this question or these type of questions because of the NTC final. Okay? So we go about doing this exactly the same way. So the very first thing that you would do is I've got 2 points, so I'm going to use the slope formula. Okay? Now I'm just going to fill in what I know. I know that the slope is -2. I know that my first y is -3. My second y is 4. My first x is +3. And my second x is k. What I'm looking for. So I know that I'm sitting here with that right now. If I wanted to make that look nice and pretty, I would say -2 equals -7 over 3 minus k. And really, this is -2 over 1, which is going to allow me to cross multiply. When I cross multiply, I get 1 times -7 is -7, and I get 2 times 3 minus k, excuse me, -2 times 3 minus k. I don't know why it's switching back to red all the time. That was supposed to be the purple. Yeah. Now I can distribute the -2. Gives me -7 equals -6 plus 2k. Then I can add 6 to both sides. Gives me -1 equals 2k. And finally, I can divide both sides by 2. And that would give me k is -1/2. So if k is -1/2, then the value of, oops, I guess I can't fit it all in on one slide, then the value or the slope between those 2 points would truly be -2. Okay? Thumbs up. Good to go. Love it. Okay. So if you are a follower of the It's Learning page, the worksheet for this week has been posted, and you can do questions 1 through 5 based off of this class. Okay? And then we'll do the rest of them the rest of the week. So, but right now, if you wanted to get started on that, you could do questions 1 through 5 on the worksheet. And if you haven't answered the question of the day yet, make sure that you answer the question of the day. And if you have some things to turn in, remember that this week, Thursday, starts the late penalty for Unit 1 stuff, because we're basically done with, well, I shouldn't say we're basically done. We are done with Unit 1, and so the week grace period is over with on Thursday of this week. Okay? That's all I got for you. Have yourselves a great, grand, and wonderful day. There will be a video tomorrow. It'll be short. It'll be sweet. It'll be riveting as always. And then there'll be another video for you on Wednesday. Okay? So we'll see you on Thursday.